Hello students, how are you? Hope you are all fine. And as per your request, I am recording this video. So, see, as you know, there are 4 part tests. For each of the part tests, we will be sending 4 assignments. Each assignment consists of 60 questions. Among those 60 questions, some of them I would like to solve here. Okay. So, let us look at the first assignment. In that first assignment, let me solve a few questions. Here, the topic for this assignment is sets, relations and functions and mathematical inductions. See students, relations and functions will appear in first year as well as in second year. So, if I restrict only to first year, then we do not get that many questions from first year syllabus only. So, for this particular chapter, I have included questions from second year also for this relations and functions. Okay. So, now let us discuss questions. Let us have a look at the first question. It is from sets. A set A has 3 elements and another set B has 6 elements. Then the number of elements in A union B. Observe, number of elements in A union B, minimum is 3, maximum is 6, minimum is 6, maximum is 9, etc. So, these are the options they have given. Okay. So, A has 3 elements and B has 6 elements. Then the number of elements in their union cannot be more than the sum of those two. Okay. See, as you know this formula, n of A union B, number of elements in A union B is equal to number of elements in A plus the number of elements in B minus the number of elements in A intersection B. So, this n of A union B will be maximum only when this is equal to 0. That means, when they are disjoint sets, suppose if this is A and this is B, they are disjoint, I mean their intersection is empty. In that case, number of elements in their union will be equal to the sum of these two, n of A plus n of B, because then this will become 0. So, their sum will be the maximum value of the number of elements in A union B. So, here A has 3 elements and B has 6 elements. Therefore, number of elements in A union B will be maximum. That maximum value is equal to sum of these two, 3 plus 6, and 9 is the maximum. But as we observe, 9 is present in 3 options. So, only one option is eliminated. Okay. Then what is a minimum element? A union B, A will be a subset of A union B, B will also be a subset of A union B. So, number of elements in A union B cannot be less than the number of elements in A and cannot be less than the number of elements in B. So, the minimum value of A union B can occur. Say here A has 3 elements and B has 6 elements. Let us say if A is a subset of B. If A is a subset of A, let us say this is A and this is B. Now, what will be A union B? A union B is same as B itself in this case. So, then that will be the minimum value. Number of elements in B will be the minimum value of number of elements in A union B in this particular problem. So, the answer is 6. Minimum is 6, maximum is 9. Hence, third option is the correct answer. Okay. Now, you might think, sir, is it true always B? That B, number of elements in B will be the minimum value of n of A union B. The answer is no. The minimum value of n of A union B is the maximum among A and B. Maximum among n of A and n of B. Among n of A and n of B, whichever has the maximum number of elements, that maximum value will be the minimum of n of A union B. Okay. So, here the answer is third option, 6 to 9. Okay, let us have a look at the next question. In a group of 1000 people, each may speak either Hindi or English or both. Each of them, they know either Hindi or English or both. There are 750 people who can speak Hindi and 400 who can speak English. Then the number of persons who can speak Hindi only is. Okay. See, this problem can be solved by using this formula. Instead of that, my advice is better you draw the Venn diagram. From there you will get the answer easily. So, let us say this is H. The H indicates the number of persons who speak, number of people who speak Hindi. And let us say this is E. E is the number of people who speak English. Okay. See, altogether 1000 people are there. All of them will speak either Hindi or English or both. Now 750 people speak Hindi and 400 English. So if I add them, 750 plus 400 I do, I'm going to get 1150. Okay, 750 plus 400 will give you 1150, but we don't have that many people. The total number of people are only 1000. So that sum of all these should give us 1000. But if I add as it is, I am going to get 1150, which suggests that there are few people who are speaking Hindi as well as English. So how many of those? Total is 1150 minus 1000. So that will give you 150, which means there are 150 who belong to their intersection. That means there are 150 people who speak both Hindi as well as English. Okay. So now Hindi total 750, here 150 I have written. So how much is remaining? 600. And English total 400, here 150, which means the remaining are 250. Now if you add them up, you are going to get 1000. That will be the total number of people. So now the question is, how many, the number of persons who can speak Hindi only. Hindi only means should belong to H and should not belong to E. Hindi only, should only speak Hindi and not English. See, if I consider these people, they speak Hindi as well as English. So I should consider only this. So how many? 600. Third option is the answer. So there are 600 persons who speak Hindi only. See, similar question could be asked like, how many people speak exactly one language? Exactly one language. Then you would add these two. 600 plus 250, then 850 would be the answer. Or you may get a question like, then how many people speak both? Then the answer is 150. How many people speak English only? That is 250. Okay. So next question. Then the number of non-empty subsets of a set containing n elements. Okay. See, you know the number of subsets, total number of subsets. If a set A has n elements, let us say A has n elements, then the number of subsets of A is 2 to the power n. Total number of subsets of A is 2 power n, that you know. Now we want the number of non-empty subsets, non-empty subsets. So here this 2 power n, where I am considering all possible subsets of A. Okay. So among them there is an empty set also. Okay. Empty set is also a subset. So that I have to subtract. So the answer is 2 power n minus 1. 2 power n will give you the total number of subsets of A, and there is one set which is that empty set which is also a subset. So that I have to subtract. So the answer is 2 power n minus 1. 1 can also be written as 2 power 0. So second option is the right answer, 2 power n minus 2 power 0. Okay, let's move to the next question. In a survey, it is found that 21 people liked product A, 26 liked product B, 29 liked product C. If 14 people liked products A and B, 12 liked product C and A, 14 people liked products B and C, and 8 liked all the 3 products. Find how many liked product C only. Okay, again students, this question can also be solved by using the Venn diagram. So let me draw those 3 sets. Let me represent it by A, B, C. Okay. So A, B, C. Now let us start with the who liked all 3. How many? 8 liked all the 3 products. All the 3 products means it should be A intersection B intersection C. That I have to write here. 8 students, not 8 students, 8 people. 8 people liked all the 3 products. So that is here. Intersection. Then 14 people liked products B and C. 14 liked B and C. B intersection C is this region. 14 of them liked B and C. Among them 8 I have written here. So remaining are 6. So observe, these 14 liked products B and C. Then 12 people liked products C and A. 12 liked C and A. C and A, 12 of them liked C and A. In that 8 we have written here. So remaining are 4. Okay. And then 14 people liked products A and B. 14 liked A and B. So in that 8 is already here. So I should write 6 now. Okay. Then. Okay. So 21 people liked product A. 21 liked product A. Say, look at the first sentence there. 21 people liked product A. In that altogether it should be 21. So here 6 plus 8, 14 plus 4, 18. Total should be 21. So remaining are 3. Then B, 26 liked product B. 26 liked product B. So total this sum should be equal to 26. Now 6 plus 8, 14. 14 plus 6, 20. So it should be 6 here. Then 29 liked product C. 29 liked product C means here 4 plus 8, 12 plus 6, 18. Total 29. Here 18 are there, remaining 11. So observe, there are, what's the question? Find how many liked product C only. So these are the persons. There are 11 persons who liked product C only. So that's the answer. 11 is the answer. Okay. See, again here you may get a question like, find the number of people who liked exactly one product. Exactly one product means 3 plus 6 plus 11, 9 plus 11, 20 would be the answer. Find the number of persons who liked B and C but not A. B and C but not A, then you should write 6. Number of persons who liked B and C, then the answer is 14. B and C but not A means 6. In that way different questions could be framed. Okay. So let's go to the next question now. Question number 9. If U is a universal set with 100 elements, A and B are two sets such that n of A is 50, n of B is 60, n of A intersection B is 20, then n of A dash intersection B dash we are asked to find out. A dash, number of elements in A dash intersection B dash. A dash intersection B dash can also be written as n of A union B whole dash. A dash intersection B dash is nothing but A union B whole dash by De Morgan's law, and this is equal to number of elements in the universal set minus the number of elements in A union B. That's equal to n of U. U is the universal set with 100 elements. So number of elements in U is 100 minus n of A union B. We know the formula already. We know n of A plus n of B minus n of A intersection B. Okay, that's equal to 100 minus of, let me substitute all these values. N of A is 50, n of B is 60, n of A intersection B is 20. So that's equal to 100 minus here 110 minus 20, okay, which is 90. That's equal to 10. So 10 is the correct answer, which is the second option. Okay, 10. Let's have a look at the next question. In a city, 3 daily newspapers A, B and C are published. 42% of the people in that city read A, 51% read B, 68% read C, 30% read A and B, 28% read B and C, 36% read A and C, 8% do not read any of the 3 newspapers. The percentage of persons who read all the 3 papers is, okay. So again this question also we can solve by using Venn diagram. There are 3 newspapers A, B and C. A, B and C. This is the universal set, the total number of persons in that city. Okay. So let us start from here, from the intersection of all 3. How many read all the 3? That they have not mentioned. That is what we have to find out. The percentage of persons who read all the 3 newspapers. So I will call it as x percent. Let us say x percent. That x only we have to find out. X percent of the people read all the 3 newspapers. Okay. So now, okay, 8% do not read any of the 3 newspapers. So they will come out. 8% is outside this circles but inside this universal set. Then 36% read A and C. 36%, observe, 36% read A and C. 36 read A and C, in that X is already here. So the remaining is 36 minus X. Okay. Then 28% read B and C. 28% read B and C, in that X is here, 28 minus X. Actually it should be percentage. Okay. So now later on we will assume that there are 100 people in that city, then these will be numbers only. 36 people will read A and C, 28 will read B and C, in that way. Okay. Then 30% read A and B. 30% read A and B, in that X is here. So remaining are 30 minus X. Okay. Then 68% read C. 68% read C. Okay. So that 68, the sum should be equal to, total should be equal to 68. I should write it as 68 minus of the sum of all these. 36 minus X plus X plus 28 minus X. One of those X gets cancelled. 36 plus 28 will give you 56 plus 8, 64. We'll have 68 minus of 64 minus X. So this will become 4 plus X. Here I should write 4 plus X. Okay. Then 51% read B. This sum should be equal to 51. So I'll write like this. 51 minus of 30 minus X plus 28 minus X. That will give you, here X gets cancelled, 58 minus X. 51 minus 58 will give you minus 7 plus X. So it will be X minus 7. Here I shall write X minus 7. Okay. Then here how many read A? 42%. So this sum should be equal to 42. So that difference should be 42 minus of 30 minus X plus 36 minus X. So this will give you 42 minus of 66 minus X, which is equal to X minus 24. 66 minus 42 will give you 24. So this will be X minus 24. Okay. So now what is the question? The percentage of persons who read all the 3 papers. Okay. See, what is the value of X? That is what we have to calculate. Now if I add all these plus these, add all these plus this 8 also, that sum should give us the total percentage. Total percentage must be 100% only. So add all this, that sum should be equal to 100. So how can I add all this? Altogether I will directly take this as 42. 42 plus X minus 7. This is 42 plus X minus 7 plus 28 minus X plus 4 plus X plus this 8 which is outside. That sum must be equal to 100. So let us see what happens. Here X gets cancelled. 28 minus 7, that will give you 21 plus 4, 25 plus 42 plus 8. 75 plus X equal to 100. So that means X must be equal to 25. So 25% of the persons read all the 3 newspapers. First option is the right answer. Okay. Then another problem of the same kind. A group of 123 workers went to a canteen for cold drinks, ice cream and tea. Okay. 42 workers took ice cream, 36 took tea and 30 cold drinks. Okay. Cold drinks, ice cream and tea. Now 42 workers took ice cream, 36 tea and 30 cold drinks. 15 workers purchased ice cream and tea, 10 ice cream and cold drinks, 4 cold drinks and tea but not ice cream. 11 took ice cream and tea but not cold drinks. number of workers that did not purchase anything. Okay, so let me draw another Venn diagram here. So I'll call this as cool drinks, ice cream and tea. Let's say indicate cold drinks, ice cream and tea indicate tea. Okay. So look here, 11 took ice cream and tea but not cold drinks. Ice cream and tea, not a good combination actually. Okay, anyway, 11 took ice cream and tea but not cold drinks. There are 11 workers who purchased ice cream and tea but not cold drinks. Ice cream and tea but not cold drinks. So 11 here. Then 4 cool drinks and tea but not ice cream. 4 of them purchased cool drinks and tea but not ice cream. So 4 here. Okay. Then what else they have given? Ten ice cream and cold drinks. Ice cream and cold drinks. 10 number purchased, that we don't know. That 10 total sum should be 10. How many here, we don't know. Then 15 workers purchased ice cream and tea. 15 workers purchased ice cream and tea. So total this here it should be 15. In that 11 is already here. Therefore this should be 4. Okay. So now 10 ice cream and cold drinks. 10 ice cream and cold drinks. In that 4 is here. So remaining should be 6. Then what? 30 purchased cold drinks. 30 cold drinks. This total should be 30. 6 plus 4, 10 plus 14 here. Remaining are 16. Then 36 tea. So 36 is tea. Here 15 plus 4, 19. So here 17. And then ice cream, how many? 42. So 10 plus 11, 21. Remaining are 21. Okay. So total 123 were there. Now we have to find out how many did not purchase anything. So what do we do? Add this sum. Then that sum should be subtracted from the total number of workers. Total is 123. So add this sum. What do you get here? 42, right? Sorry. 20 plus 10, 30 plus 21 plus 11 is 32 plus 17. 62 plus 17, 79. So 79 people, 79 workers purchased something or the other, either tea or ice cream or cold drinks. We have to find out how many did not purchase anything. So 123 minus 79, 21 plus 23, 44 is the answer. 44. Fourth option is the correct answer. Okay. Let's go to the next question now. Let S is equal to the set of points inside the square, T is equal to the set of points inside the triangle, and C indicates the set of points inside the circle. S for square, T for triangle, C for circle. If the triangle and circle intersect each other, triangle and circle, they intersect each other. This is T, this is C. Okay. Intersect each other and are contained in a square. These two are contained in a square. That means these two, the triangle and the circle, they lie inside another square. They lie inside this square. They are contained in this square. Okay. Then what happens? Okay. What happens? You can observe this T and C, they are the subsets of S. Let us verify the options. S intersection T intersection C is equal to empty. S intersection T intersection C is this region, right? The intersection of all three. So it is non-empty. First option is ruled out. Then S union T union C is equal to S. S union T union C is equal to C. That's not correct, but this is correct. As you can observe, this S is the superset. T and C are the subsets of S. So the union of all three must be equal to S itself. So third option is the right answer. Then 16th question. The set A is equal to X such that modulus of 2x plus 3 is less than 7. Okay. modulus of 2x plus 3 is less than 7? Today. Okay. So, look at this question. The set A is equal to x such that mod 2x plus 3 is less than 7 is equal to which set? That is the question. Okay. So, mod of 2x plus 3 is less than 7. Mod 2x plus 3 is less than 7 means 2x plus 3 is less than 7, but it is greater than minus 7. Okay. So, whenever you see mod x, remember this students, if you see mod x is less than or less than a, this implies that x is greater than minus a, less than a. If you see mod x less than or equal to a, then you should write x is greater than or equal to a, greater than or equal to minus a, but less than or equal to a. And on the other hand, suppose if you see mod x is greater than a, its meaning is either x is greater than a or x is less than minus a. So, remember this point. So, in this case what they have given, modulus of 2x plus 3 is less than 7, which means 2x plus 3 is greater than minus 7 but less than 7. Now, I will subtract 3 from this inequality, that will give you minus 10 less than 2x less than 4. Divide by 2, that will give you minus 5 less than x less than 2. So, the answer is x should be in between minus 5 and 2. So, x is between minus 5 and 2, options are not there, but look at this option, x plus 5 lies between 0 and 7 they have given. Let us check. So, add 5 to this inequality, adding 5 to this inequality will give you 0 less than x plus 5 less than 7. When x lies between minus 5 and 2, x plus 5 will lie between 0 and 7. So, option D, first option, the set D is the correct answer. Okay. Then next question, 20th one. Let n is equal to 1, 2, 3, 4, etc. There is a set of all natural numbers. A is x such that x belongs to n and 2x plus 1 is greater than 10. X is a natural number and 2x plus 1 should be greater than 10. That means 2x is greater than 9. X is greater than 9 by 2. So, x is greater than 9 by 2. So, 4.5. The set A should be the set of all natural numbers where that natural number x should be greater than 4.5. Greater than 4.5 means A is 5, 6, 7, 8, etc. This is A. N is the set of all natural numbers 1, 2, 3, 4, 5, 6, 7, 8, etc. Now, we are asked to find out n minus a. N minus a is equal to, what are the elements of n minus a? The elements which belongs to n and does not belong to a. All those elements which are the members of n but not the members of a, I should write here. Members of n should belong to n, should not belong to a. Belong to n, should not belong to a means 1, 2, 3, 4. These are the 4 elements which are the members of n, but they are not the members of a. So, this is the answer 1, 2, 3, 4, which is the second option. Okay. Let us go to the next question. For real numbers x and y, define x related to y if and only if x minus y plus root 2 is an irrational number. Then the relation R is it reflexive, symmetric, transitive? None of this. Okay. So, this is a question from relations. Relations, as you know, the types of relations. Reflexive relation. A relation is said to be reflexive if every element of that set is related to itself. If every element is related to itself, then it is called a reflexive relation. A comma A belongs to R for all A in that set. Then symmetric relation. Symmetric relation means AB belongs to R should imply BA belongs to R. That means if A is related to B, then B must be related to A. Okay. So, then transitive. Transitive means A is related to B and B is related to C should imply A is related to C. AB belongs to R and BC belongs to R. If it implies that AC belongs to R, then we can say that that relation is a transitive relation. Okay. So, now here that relation is defined as x minus y plus root 2 is an irrational number. Okay. So, let us check whether it is reflexive or not. Okay. So what do we do? A comma A. A comma A means what do you get here? A minus A plus root 2. A gets cancelled. We get root 2. Root 2 is an irrational number. Therefore, this is true for any real A you take. Hence, it is a reflexive relation. Okay. Then is it symmetric? So, obviously, as far as this question is concerned, this is the answer, reflexive. That's okay. Now, I'll explain you why it is not symmetric. Why it is not symmetric. For example, if I take root 2 comma 1, this belongs to this relation, root 2 comma 1, because if I substitute here root 2, x as root 2 and y as 1, I am going to get root 2 minus 1 plus root 2, which is equal to 2 root 2 minus 1. This is an irrational number. Okay, this is an irrational number. Therefore, root 2 comma 1 belongs to R. But what about 1 comma root 2? 1 comma root 2 if I take, I am getting 1 minus root 2 plus root 2. Here root 2 gets cancelled. We get 1. 1 is not an irrational number. Therefore, 1 comma root 2 does not belong to R. So, AB belongs to R, but BA does not belong to R. AB belongs to R, but BA does not belong to R. Therefore, this relation is non-symmetric. Okay. Now, I will tell you why it is non-transitive also. Okay. So, okay. So, now I will take relation such that AB belongs to R, BC belongs to R, but AC does not belong to R, right? That is what I need. Okay. So, I will take root 2 comma 1, this belongs to R, and 1 comma 2 root 2 I will take, that will also belongs to R, because 1 comma 2 root 2 means I am going to get 1 minus 2 root 2 plus root 2. So, that is an irrational number. So, AB belongs to R, BC belongs to R, but AC means root 2 comma 2 root 2. Now, let us see what happens. If I take x as root 2, y as 2 root 2, then I am going to get a root 2 minus 2 root 2 plus root 2. 2 root 2 minus 2 root 2, this is equal to 0, which is not an irrational number. So, observe that AB belongs to R, BC belongs to R, but AC does not belong to R. Therefore, this is not a transitive relation. So, it is only a reflexive relation. Next question. If a set has n elements, then the number of relations on A. Number of relations. What is a relation? A relation is a subset of A cross B. If A and B are two non-empty sets, a relation from A to B is defined as the subset of A cross B. So, any subset of A cross B is a relation from A to B. Now, we want the number of relations on A. So, a relation on A is a subset of A cross A. Okay. So, how many relations are there from A to A? For that, what we need to find out is how many subsets are there for A cross A. Now, A has n elements. A has n elements. Then what will be the number of elements in A cross A? A cross A will have n into n, which is n square. Okay. So, n square is the number of elements in A cross A. If A has m elements, B has n elements, then A cross B will have mn elements, right? Their product. So, now I am talking about a relation from A to A. So, for that I need a subset of A cross A, the number of subsets of A cross A we need. So, these are the number of elements in A cross A. Okay. So, if a set has n elements, then the number of subsets is 2 to the power n. Now, here the set means I am talking about A cross A now, which has n square elements. So, the number of subsets of this is 2 power n square. Number of subsets itself is the number of relations from A to A or relations on A. So, 2 power n square is the right answer, first option. Then 29th question. Let R be an equivalence relation. on the set Z of integers given by R is equal to A comma B, we say A is related to B if 2 divides A minus B. 2 divides A minus B is the relation. Okay. Then the equivalence class of 0 is equivalence class. Equivalence class of an element is the collection of all those elements which are related to this element. Okay. So, equivalence class of 0 is the set of all elements which are related to 0. Okay. So, let us verify 0, is it related to itself? Yes, 0 minus 0, because it is an equivalence relation, and you say 2 divides 0 minus 0, 2 divides 0, yes, 0 does not divide 2, but 2 divides 0, 2 into 0 is 0. So, 0 is there, and 1, 0 comma 1, does it belong to this relation? No, because 0 minus 1 if I do, I am getting minus 1, and 2 does not divide minus 1, 2 divides only even numbers, right. So, I cannot write 1, I cannot write 3, 5, but I can write 2, because 0 minus 2 is minus 2, 2 divides minus 2, I can write 4, I can write 6, I can write 8, and I can write those negative values also. Okay, so that is the answer. 0 plus or minus 2 plus or minus 4 plus or minus 6, etc. Okay, because if I take a look at this, 3 if I take, 0 minus 3 is minus 3, but 2 does not divide minus 3, 0 is not related to 3. Although 0 is related to 6, but not related to 3, not related to 9, not related to 1, not related to 3. Therefore, second option is the answer. Equivalence class means the set of all the elements which are related to that particular element. Okay. Let us look at the next question. Question number 30. Let S be the set of all real numbers. A relation R has been defined on S by A is related to B if and only if modulus of A minus B is less than or equal to 1, then R is. Modulus of A minus B is less than or equal to 1. Okay. So, now we will check whether it is reflexive or not. To check whether it is reflexive or not, what do? I will take the element A comma A. Okay. So, now A minus A, what do you get? 0. 0 is less than or equal to 1, obviously, it will hold good. So, it is a reflexive relation. Then is it symmetric or not? If mod A minus B is less than or equal to 1, can I say what is mod B minus A is also less than or equal to 1? Yes, obviously, because these two are one and the same. Since you have modulus here, modulus of A minus B is same as the modulus of B minus A. If this is less than or equal to 1, this is also less than or equal to 1. Therefore, it is symmetric also. Now, the question is it transitive? Let us say A minus B is less than or equal to 1. Mod A minus B is less than or equal to 1. That means A comma B belongs to R. Then, mod B minus C is less than or equal to 1. That means B comma C belongs to R. Then the question is, what about A minus C? Is it less than or equal to 1 or not? The answer is no, need not be. Okay, let us verify with one example. I will take one example and show you why this is non-transitive. Okay, I will take 1 comma 0. 1 comma 0. A is 1, B is 0 I will take. So, 1 comma 0 belongs to R, because 1 minus 0 if I substitute, I am getting 1. 1 is less than or equal to 1, holds good. Then I will take 0 comma minus 1. 0 comma minus 1. Then what do you get? 0 plus 1. That is 1 less than or equal to 1. This also belongs to R. So, AB belongs to R, BC belongs to R. Then what about AAC? 1 comma minus 1. Put A as 1, B as minus 1, or C as minus 1 here. We get 1 plus 1, 2. 2 is not less than or equal to 1. So, this does not belong to R. So, as you can observe, AB belongs to R, BC belongs to R, but AC does not belong to R. Therefore, this is not a transitive relation. It is reflexive and symmetric, but not transitive. So, third option is the answer. Okay. Students, the remaining questions I will solve in my next video. Thank you.